Hi guys, this is the second part for your video. We started to tape that first video during 6th bell because we had quite a bit of time left that we could start on those second set of notes or start naming molecular compounds. Now, for your naming of molecular compounds, we've been looking at a page that looks like this. If you look at the bottom of this page, that I also attach this to your blog on that website, or on your blog on that specific post is what I meant to say. So look at your prefix names and then also the number of atoms for each of those names, because I want to go back over that. And actually, I want to go back over even before that, where I asked, why do we use prefixes for covalent compounds, but we don't use prefixes for ionic compounds? The reason that we don't use prefixes for ionic compounds is because ionic compounds are based only on charges. And we know that the charge of aluminum is always going to be a +3. And the charge of chlorine is always going to be a -1. So if I have Al with a +3 charge, and I have Cl with a -1 charge, the formula for aluminum chloride will always be AlCl3. So it doesn't matter how many of each atom I have. It matters because, I'm always going to get the same formula. I'm always going to get AlCl3 for aluminum chloride. Now that's different in terms of nitrogen and oxygen. So if we were to think about nitrogen and oxygen as crisscrossing charges, if we had nitrogen and we had oxygen, well, we typically think about nitrogen as having a -3 charge and oxygen as having a -2 charge. And we know that in an ionic bond, there has to be a positive charge and a negative charge, right? There has to be a cation, there has to be an anion. So that's number one, why I can't use charges when we're going to name molecular compounds, which are between two nonmetals. But let's say we crisscross these charges into O3. This may not always make into O3. So because it may not always make into O3, I can't just use charges based on nitrogen and oxygen. Sometimes we have compounds with nitrogen and oxygen that are just NO. Sometimes we have one that's NO2. Sometimes we have one that's NO3. Sometimes we have into O5. So we can have a bunch of random nitrogen and oxygen combinations of molecular compounds. So how I name them is based on prefixes because it tells me how many of each atom are present in that compound. So that's why we have to use prefixes for molecular compounds or for covalent bonds. Now, for your names, we went through today in the first video and talked about, in terms of the name, the prefix names. So if I have one atom, the prefix for 1 is mono. Prefix for 2 is di. The prefix for 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So those are the prefixes that I'd like you to fill in the prefix name that corresponds with that box. Now we started to talk about the rules for naming. So we know if we want to name a compound, that the first compound name is just going to stay the same. But there's one little exception to this. So if we had, for example, let's do NO. So first element is nitrogen, so we're just going to name that nitrogen. But if there's more than one of the first element that you have, then we have to add a prefix to it. So let's say we really had N2O5 as our compound. Well, I have 2 nitrogen atoms here, so I'm going to have to call it, since I know there's 2 and the prefix for 2 is di, I'm going to call it dinitrogen. Okay, so there's the difference in when we're naming that first atom. So if it's all by itself, it's just the name of the element. Nothing else changes. If it's more than one element, if I have 2 or 3 or 4, I have to use the prefix and then just the rest of that name. Now, in terms of naming the second atom, I'm going to name that second atom by always adding a prefix in front of that second name. The second name, regardless, should always have a prefix in front of it. Now, just like we name an ionic compound where we change the ending to an "ide," we're going to do the exact same thing. So really we're doing something very similar to ionic naming, but now we have to add that prefix in front of it for this second atom or second element. So if I look at these, this would be nitrogen. So that was my N, we just said that, and it's bonded to oxygen. So instead of oxygen, I'd call it oxide, but I have only one of them, so I'm going to call it monoxide. So this is nitrogen monoxide. Okay, now let's look at N2O5 again. So we just said that we would name N2 dinitrogen. Okay, well now I know that the second element always gets a prefix. There's 5 of them. So that's penta. And I know that oxygen, I need to change that to where it has an IDE. So I would call this dinitrogen pentoxide. Okay, so some of you may have written pentaoxide, but we don't need those 2 vowels there. We will typically just kind of like drop that A. So it would just be pentoxide, okay? Let's do some more practice ones with these. I have some on the back of that paper. So we just did NO. Let's do N2O, which... Okay, if we were to do N2O, that would be 2 nitrogens. So I would say dinitrogen, and I have to say the di because there's more than 1 nitrogen present in that first one. So I'd say dinitrogen, I have 1 oxygen, and I know I need to change that second one to where it ends in IDE. So I would say dinitrogen, there's 1 of them, so it's mono, so monoxide. Dinitrogen, monoxide. Okay, look at the next one. The next one says NO2. Now note that this is not nitrite because NO2 here does not have a charge next to it. So if I had NO2 with a -1 charge, then that would be nitrite. But this doesn't have a -1 charge on it, so this is a molecular compound. So don't get confused by looking at nitrite and then this NO2. The difference is the charge. So if I see NO2 with a -1 charge, that's that polyatomic ion nitrite. If I see no charge here, which you don't, then that's a molecular compound that we're going to name right now. So first element is nitrogen. I just have 1 of them, so I don't need to use a prefix for that. So I'm just going to call nitrogen. And what would be the second part? There's 2 oxygen. I need to change that to an IDE. So how would you name it? If you said dioxide, you are awesome. So we have nitrogen dioxide. Let's look at the next one. The next one we have N2O3. How would you name this one? Try that one on your own.
Hi, Miss Warren.
Hi, Miss Warren.
What should we be trying on our own?
On your video. Guys, Greg and Amar are saying hello.
Hi.
Yeah, track. It's gonna be great.
Okay, guys, so N2O3, if you try this on your own, hopefully you wrote down dinitrogen. I have 3 oxygen this time, so 3 is tri. So this would be dinitrogen trioxide. Okay, let's try a few more. We'll do 2 or 3 more, just to make sure we are all on the same page. Okay, what if I gave you N2O4? Okay, N2O4. If you tried this one, what would you say? Hopefully you would say dinitrogen tetraoxide. Well, which we would say just tetroxide. Because you can just drop that A. So it would just be dinitrogen tetroxide. If we look at the next one, that's N2O5. Very similar. It would still be dinitrogen, but now that there's 5 oxygen, we would say pentoxide. Okay? Let me give you a different one. PBr3, both nonmetals. P is phosphorus. There's only one of them, so I would say phosphorus. Phosphorus, what would you say? Tribromide. Woo! Okay, guys, I hope that going through some of these examples helps you realize or kind of learn these rules. Now, if you have questions on them, let me know. I will have a copy of this for you tomorrow when you come to class, but if you want to print out a copy at home and fill in those blanks, then that would be awesome too. But again, if you don't have a printer, I have a copy of this for you. Just make sure that you take some notes down on the video so that way you kind of know and can follow along with what we're talking about. So I will see you tomorrow, and have a good night. Bye.